Hello friends, today we are going to see the second chapter of Computer Science 2, that is Introduction to Instruction Set and Programming of 8085 microprocessor. In this lesson, first we are going to understand the way in which you can identify the instructions depending upon their length, depending upon the way the data are transferred. So let us see how we can divide them. Okay, you can see here the grouping of the instruction according to the length. Now over here, the meaning of length is whether the instruction is of 1 byte, 2 bytes or 3 bytes. Now to give the meaning to this, what is the meaning of instruction of 1 byte or 2 bytes or 3 bytes? Let us see some example here. There is one example of an instruction called move AB. This is an instruction, move the contents of B to accumulator. So the meaning of this instruction is understood by the microprocessor by only putting 1 byte, that is the opcode, and the opcode for that is 78. You need not study what is the opcode for each of the instruction, but to give an example, I have noted some examples here. What you need to know is how this move AB works. So that we will see in the later slides. So you can see here 78, when the instruction sees the 78, depending on the position of that 78, sometimes in the program 78 can be the data also. Okay, so depending upon the position of the 78 in the program, when you are entering into the microprocessor kit, so it takes that 78 as internal meaning, shift or transfer the data from B register to accumulator. So this is a single byte instruction. Next is a 2 byte instruction. Now what do you mean by 2 byte instruction? If you consider this example, move B, move the contents of or move immediate data 05 to B register. So how do you write that? You write it as 0605. So what is 06? The opcode for move immediate B, that is operation code for move immediate B, and 05 is the immediate data. So when you see here, this is 1 byte, this is second byte. So this full 2 bytes gives the meaning that move this data 05 to register B. Yes, so that is, these type of instructions are 2 byte instructions. So what are those 2 bytes? One is the operation code, the next one is the immediate data that you mention in the instruction. It can be MVIB07 also. Means what? The opcode that you are going to pass it is 06 as it is, and you are going to change this 05 to 07. So this both together gives the full meaning of this instruction, which is of 2 bytes. There is one more type which is called as 3 bytes instruction. So again here the 3 bytes total together gives the full meaning of that instruction. For example, STA 3000. So what is the meaning of STA 3000? Store the contents of accumulator at a memory location 3000. So when you want to say that I want to store the contents of accumulator into the memory location 3000, what is that you are going to tell to the microprocessor? That, or in what way you are going to tell that I am going to send this 32 first, and then 00 and then 30. What is 32? 32 is the opcode for STA, that is operation code for STA, and out of this 3000, 00 is the lower byte and 30 is the higher byte. So when you are passing into the microprocessor, it is always the first opcode, second is the lower byte of the address, so this is the address, and third byte is the higher byte of the address. So how do you pass it? 320030. If you have something like STA 3030, then it will be S323030, or STA 3050, then it is 3250 and 30. So this is how you're going to enter into the microprocessor. I hope this is clear, that any instruction can be of either 1 byte or 2 byte or 3 bytes. Now, coming to another way of grouping the instructions is based on the functioning. Now, what type of function it is doing, depending upon that, all the instructions of the microprocessor 8085 have been divided in a broad category of 5 groups, which is first one data transfer, second one arithmetic group, third is logical group, fourth is branching group, and the fifth one stack and machine control group. Okay, now coming to data transfer, as the name suggests, whenever you want to transfer the data from one location to another, one register to another register, or you want to put some data into some register or into some memory, shifting from like let us say accumulator to some address, all those address to accumulator, all these data transfer function is having some instruction. So each instruction has its own meaning. So those like where you find that transfer of data, so those instructions come under data transfer group. Next coming to is the arithmetic group. As you can see, arithmetic, the meaning itself says whenever or whichever the instruction is playing a role of arithmetic operation, they are coming under arithmetic group. So arithmetic can be what? Addition, subtraction. So there is no multiplication and division direct instruction in 8085. You have to go for multiplication and division using this addition and subtraction only. So arithmetic instructions coming are addition, subtraction, increment, decrement, and there is one special instruction called as you are changing the data from the hex to binary coded decimal type. Means if you want to say 10 in decimal, but we write it as A. So if you want to show the answer as 10 instead of A, then you have to pass it through that decimal adjust accumulator instruction. That is okay, we are going to learn that in detail, but you should know that there is something of this kind also. After that, we have a logical group. So this logical group is having instructions where all logical operations are involved. Logical ANDing, logical ORing, logical exclusive ORing, and complementing. So shifting the data, all that is coming under logical group. Okay. Next is branching group. So when I say branching, it is you are jumping from one location to another location depending upon condition or no condition. So you are branching from the main program to the next part of the program in the main program itself, or you are branching from one program to another program. So it is possible, and the instructions which are related to jumping within the program or jumping from one program to another program and coming back, all that comes under branching group of instructions. Next we have is stack and machine control group. As the name suggests, stack and machine control, it is related to the operation of the stack and the controlling of the machine. For example, when I say controlling of the machine, you want to do nothing in the execution of the program. So you have NOP, no operation. So or else halt, or disable interrupt, or enable interrupt. All these kind of instructions are coming under stack, a machine control group of instructions, and stack and machine control together they are put where one part is related to stack operation, the other part is related to other part of the not the same program, means some program, some instructions belongs to machine control group. Okay, before trying to understand the actual instructions of 8085, I have given you one program here. Means how are we going to use the instructions in the program? Okay, so suppose the program is to, there is a program where you have stored B with 05. What is the meaning of MVI B05? Store B with 05 means what is there in B? 05. Now next instruction is whatever is there in B, put it in C register also. Means at this point C content is also 05. Next you have accumulator is stored with 09H, MVIA 09H. And whatever is there in A, you are shifting to D register. D is also having 09, and then you are ending. So What can be the question for this program is store 05H in B and C register and 09 in A and D register. What? Write a program to store 05 in B and C register and 09H in A and D register. So for that what you write? MVIB 05H, move the contents of B to C, move immediate A with 09 and move the contents of accumulator to D and then stop processing. Okay, so this is how we have to use the instructions, and this is what is the comment for each of the instruction. What is the meaning of comment of each of the instruction? What is the meaning of this? Move immediate data 05 to B register. Whatever is the content of B, shift it to C register. Or move 09 to accumulator, and again whatever is there in A, shift it to D register and stop processing. So these are called as the comments of a particular program. Comments are equally important in writing the program. In your board exam, it is going to carry 1 mark. Comment specially carries 1 mark. Okay. Okay, I have given you one more program here. That is program for addition of two numbers stored in C1000 and C1001 and store the result in C1002H. So what is the meaning? There is some data in C1000, there is some data in C1001 also, and whatever the addition of C1000 and C1001 you do, store that in C1002. Okay, so first we have to point to C1000. So the instruction that we are going to use is LXI H C1000. So the meaning of this instruction is store C1000 in H and L pair. So then is move the contents of memory to accumulator. Here the meaning of memory is something or some location whose address is there in HL pair. So for that reason we have put that address in HL pair. So when you are putting this as C1000 in HL pair, so that C1000 we can refer it as memory. If you put it in BC pair of register, it is not possible. Okay, so it has to be there in HL pair of register. So what we did, point to the location, take it to accumulator, go to the next memory location. What is the meaning of INXH? Increment this HL pair. So C1000 will become C1000 1 year, and then add memory. So when I say add memory, what is added? The contents of memory, means what the content of C1001 is added to accumulator. What is accumulator? The content of C1000. So when you do add M, it is the addition of content of C1000 and C1001H. Whatever is the result which is there in accumulator, you have to shift it to what? C1002. So for that you have to go to the next memory location. So you are making it as increment HL pair and shifting that data of accumulator to memory and then ending it. So this is how you are writing the program. Okay. Okay.